some steam turbine. So see here some historical fact. The first turbine was made by Hero of Alexandria in the 2nd century. In the end of century, the industrial revolution began in 1771. Reciprocating piston steam engine invented by Thomas Newcomen and invented by James Watt started its work. This is brief history of the steam turbine invention. See, the first steam turbine were constructed in 1883, Revel, and in 1884 by Charles Parson. In 1896, Charles Custis received a patent in impulse turbine, and in 1910 was created radial turbine. This is brief history of steam turbine. Now, what is steam turbine? So, steam turbine convert a part of energy of the steam evidenced by high temperature and pressure into mechanical power, in turn electrical power. Means simply convert a steam energy into rotary energy, means in the steam energy means in the form of temperature and pressure. This energy convert into rotary energy or mechanical energy, and from this rotary energy and mechanical energy we have produced electricity. This is steam turbine work. So this steam from the boiler is expanded in nozzle, resulting in the emission of high velocity jet. This jet of steam impact on the moving vane or blades mounted on shaft. Here it undergoes a change of direction of motion, which gives rise to change momentum and therefore a force. So see here, the motive power in steam turbine is obtained by the rate of change of momentum of high velocity jet of steam impact on the curve blade, which is free to rotate. The conversion of energy in the blade takes place by impulse reaction principle. So the steam of boiler is expanded in nozzle, so resulting in emission of high velocity. So steam produced by boiler and coming through pipe to the nozzle. In the nozzle, our steam is expand suddenly at the time of emission. So increase velocity of the steam in the nozzle. So we are getting very high energetic steam from nozzle, removing from the nozzle. So we have used nozzle for that purpose. So this jet of steam impact on the moving vanes. This steam impacting on the blades or moving vane of the turbine mounted on the shaft. Here it undergo or change the direction of motion, which gives rise to change in momentum and therefore a force. The motive power in steam turbine is obtained by the rate of change in momentum of high velocity jet of steam impact on curve blade, which is free to rotate. The conversion of energy in the blade takes place by impulse reaction principle. Okay, the conversion of energy in the blades takes place by impulse reaction or impulse reaction principle. So principle of operation of steam turbine. Any doubt, any queries in this? What is steam turbine? Hello? Any doubt, any queries? All of you got it? Getting this point? So, principle of operation of steam turbine. The steam turbine depends completely upon the dynamic action of the steam. So, according to Newton's second law of motion, the is proportional to force is proportional to the rate of change of momentum mass x velocity in x direction if the rate of change of momentum is caused in the steam by allowing high velocity jet steam to pass over curved blade, the steam will impart a force of the blade. If the blade is free, it will move off in the direction of the force. So C1 is the initial velocity, C2 is the final velocity. One minute. See here, if the rate of change of momentum is caused in the steam by allowing high velocity jet steam to pass over curved blade, the steam will impact the force to the blade. If the blade is free, it will move off or rotate in the direction of force. So C1 is initial velocity, C2 is final velocity. We can see in this diagram steam enter from this direction and goes to the at this direction means C2 direction and force impact of force in this direction. This is blade and force in this direction. So see the steam coming from this direction like that and going to this direction, force acting on this direction. Okay. All of you clear this principle of operation of steam turbine? Any doubt, any queries? Please ask me. Okay. So principle of operation, a nozzle in which heat energy of high pressure steam, a nozzle in which heat energy of high pressure steam is converted into kinetic energy so that steam issue from the nozzle with very high velocity. Blade which change the direction of steam issuing from the nozzle so that force act on blade due to change of momentum and rotates them. So the basic principle of operation, a steam turbine is generation of the high velocity steam, a jet by expansion of high pressure steam in nozzle, and motive power in the turbine is obtained by change in momentum of the high velocity steam jet by allowing it to impact of curved blades. So steam turbine are steady flow machines, have large exhaust outlet for discharge use steam, and the speed of flow is very high, so they can handle large volume of steam and produce higher power, and the process are assumed to be adiabatic. Steam turbines are capable of expanding steam to the lowest exhaust pressure obtainable in the condenser. The turbine is a constant high-speed machine and really must be operated condensing in order to take full advantage of greater range of steam expansion. See here, steam turbine are steadily flow machines, have a large exhaust outlet for discharging used steam, and the speed of flow is very high, so they can handle large volume of steam and produce higher power, and the process are assumed to be adiabatic. Steam turbines are capable of expanding steam to the lowest exhaust pressure obtainable in condenser. The turbine is constant high-speed machine and really must be operated condensing in the order to take full advantage of greater range of steam expansion. So here we can see in this figure velocity of steam, direction of steam and impact of steam on the blades. And also right hand side we have seen the relationship between work force and blade velocity. Work force and blade velocity can be expressed in the other graph. So work in turbine visualize. High temperature in this diagram we have seen high temperature, high pressure, high velocity steam in on the turbine and steam out low temperature, low pressure and low velocity. So using temperature, pressure and velocity, we are using this power in the form of rotary power, and rotary power produce electricity. Simple work. Means high pressure, high temperature, high velocity of the steam convert into low pressure, low temperature, low velocity, and losses of this steam we have used for the production of electricity. This is simple work of the steam turbine. So steam turbine classification. Steam turbine can be classified in several different ways by detail of stage design, impulse or reaction, means by details of stage design, impulse turbine and reaction turbine, by steam supply and exhaust condition, condensing or non-condensing, automatic or controlled extraction, mixed pressure and reheat, by casing or shaft arrangement. According to by casing and shaft arrangement, single casing single casing, tandem compound and cross compound. By number of exhaust stage in parallel, by casing or shaft arrangement, single casing, tandem compound and cross compound, by number of exhaust stage in parallel, 2 pro, 4 pro and 6 pro, by direction of steam flow, axial flow, radial flow, tangential flow, single or multi-stage, by steam supply, classification based on action of steam, impulse turbine, reaction turbine, combination of impulse and reaction turbine, based on number of pressure stages, single stage, multi-stage, impulse and reaction turbine, based on direction of steam flow, axial turbine, radial turbine, based on number of cylinder, based on number of cylinder, single cylinder, double cylinder, three cylinder and four cylinder, like that. Now, main classification of steam turbine, impulse turbine and impulse reaction turbine. Impulse turbine and impulse reaction turbine. So see types of steam turbine mainly classified impulse turbine and reaction turbine. The process of complete expansion of the steam takes place in stationary nozzle and the velocity energy is converted into mechanical work on the turbine blade. What is major difference between impulse turbine, impulse steam turbine and reaction steam turbine? In impulse turbine, see a process of complete expansion of the steam take place in stationary nozzle and the velocity energy is converted into mechanical work on the turbine blade. The pressure drop with expansion and generation of kinetic energy takes place in the moving blades. In the reaction turbine, pressure drop and expansion of pressure drop with expansion and generation of kinetic energy takes place in the moving blades, like that. This is major difference between impulse turbine and reaction turbine. Now the impulse principle, it is impossible to have 180-degree curve blade in actual application. Jet exit will impact on the back of the neck blade. The blade entrance angle and blade exit angle cannot be zero as shown in figure below. So this is here impulse turbine blade, axis of rotation, impulse turbine principle blades. So see here, this is impulse turbine principle water, we have seen in water turbines, water coming from the penstock and impacted on this blade, and this blade rotates clockwise, anti-clockwise, mounted on the hub mounted on the rotor, and our shaft is rotated. So same principle here apply for steam turbine. Only media is changed. In the water turbine, we have used water, and steam turbine, we have used steam for the production of electricity. So types of impulse turbine. In this figure, we have seen this steam turbine rotated by generation of steam. Now we have seen impulse turbine, reaction turbine. Now types of impulse turbine, simple impulse turbine and compounding of impulse turbine. So impulse turbine, the basic idea of impulse turbine is that a jet of steam from the fixed nozzle pushes against the rotor blade and impact the forward, impulse the forward. The velocity of steam is twice as fast as the velocity of blade. Pressure drop takes place in the fixed blade nozzle. Blade is usually symmetrical. Entrance angle phi and exit angle gamma are, and exit angle gamma are around 20 degrees. Usually used in entrance high pressure stage of the steam turbine. Enthalpy drop and pressure drop occur in the nozzle. We can see here in the diagram steam coming from the boiler impacting on the our steam turbines blades like that. This is our nozzle. After steam coming from boiler through the nozzle, this nozzle at the steam removing from the nozzle at high velocity, high pressure and high temperature. Using this high velocity, high pressure, high temperature, we have used this power to rotate our steam turbine and produce electricity like that. This is totally blade mounted on this hub. This is cross-section view. Sorry, this is cross-section view, this is side view. Now, simple impulse turbine. It is impulse turbine where the steam is expanded within the nozzle and there is no any change in the steam pressure as it passes over the blade. It means that the pressure remains constant through turbine. Single stage impulse turbine is called de-level turbine. Arrangement of impulse turbine. This is arrangement of impulse turbine, simple impulse turbine. This is shaft. On this shaft, here mounted, hub mounted. On this hub, blades are mounted. This is nozzle. Here blades. This is casing. De-level turbine diagram shown in this figure. A de-level turbine named after Swedish engineer de-level is the simplest impulse turbine and is commonly used. The essential part of impulse turbine are nozzle, blade and casing. See, this is wheel, this is shaft, this is nozzle and this is blade. We know already. Now, impulse turbine, in impulse turbine, the enthalpy drop completely occurs in the nozzle itself, and when the fluid pass over the moving blade, it will not suffer pressure drop again. In impulse turbine, the enthalpy drop completely occurs in the nozzle itself, and when the fluid passes over the moving blade, it will not suffer pressure drop again. Hence, the pressure remains constant when the fluid passes over the rotor blade. Show the schematic diagram of impulse turbine. See, this is impulse turbine diagram. In this diagram, we can see a steam coming from the nozzle impacting on this blade and move like that according to surface of this blade like that. See here, steam coming from here and go according to blade profile and removing like that. So this is here high velocity of steam, here low velocity of steam, resultant force in x direction like that. See, at the steam enter in the nozzle, at the time of steam enter in the nozzle, inlet velocity is low and pressure is very high. After steam passing through nozzle, after that steam removing from the nozzle, at that time our inlet velocity is very high and boiler pressure is low, means pressure energy convert into kinetic energy, means increase KE, and this high kinetic energy impacting on the blades, and pressure is constant on this blade. So see here, using this kinetic energy, our blades are rotate clockwise or anti-clockwise direction, depend on the situation. So see here, only simple phenomenon here, pressure energy convert into kinetic energy in the nozzle, and very high velocity of steam impacted on the blades. That's why we are getting more force. Delivery level impulse turbine, same procedure. See, this is nozzle, this is our turbine. At the time of turbine, sorry, at the time of steam removing from the nozzle, steam removing from the boiler, coming to the nozzle, our velocity is very low and pressure is very high. After going through the nozzle, steam going through the nozzle and removing from the nozzle, at that time, our pressure energy is low, pressure is low and velocity is very high. In between nozzle, pressure convert into velocity, means pressure energy convert into velocity, and velocity increases. This high velocity means high kinetic energy convert into mechanical energy, and pressure is constant. This is our impulse turbine, steam turbine principle. Very simple principle for understanding. So, impulse turbine nozzle blades arrangement. See here, this is 3D diagram of impulse turbine nozzle blade. This is nozzle, and this is cloud, this is blades like that. We can see here, this is blade, this is wheels, this is blade mounted on this wheel. This is our nozzles like that. Now this diagram shows impulse turbine staging. So first we nozzle, moving blade, fixed blade against moving blade. This is so nozzle and moving a blade. This is first stage. Fixed blade and moving blade. This is second stage. See, in this process, what effect of our pressure and velocity in this steam going through this process, nozzle, moving blade, fixed blade, moving blade. So, what affected on steam pressure and steam velocity? So, see here, in nozzle, our pressure is dropped and velocity is high. But in moving blade, our pressure is constant and velocity slightly goes to the slightly decrease. In fixed blade, pressure also constant and velocity also constant. So moving blade, once again pressure constant and kinetic energy is decreased. So compound of impulse turbine. Compounding is a method of reducing the rotational speed of the impulse turbine or practical limits. So if the high velocity of steam is allowed to flow through one row of moving blade, it produces a rotor speed of about 30,000 RPM, which too high for practical use. Living loss is also very high. It is therefore essential to incorporate some improvement in the simple impulse turbine for possible by making use also to achieve high performance. This is possible by making use of more than one set of nozzles, blades, rotor, and in series keyed to common shaft, so that either the steam pressure or the jet velocity is absorbed by the turbine in stages. The weaving loss also will then be less. This process is called compounding of steam turbine. The weaving loss is also very high. It is therefore essential to incorporate some important in the simple impulse turbine for possible by making use also to achieve high performance. This is possible by making use of more than one set of nozzle, blades, rotor in series keyed to common shaft, so that either steam pressure or the jet velocity is absorbed by turbine in the stages. The weaving loss also will be the less. This process is called compounding of steam turbine. The steam produced in the boiler has got very high enthalpy. In our turbine, the blade velocity is directly proportional to the velocity of steam passing over the blade. Why compounding is required? This topic where we will start in next lecture. Next lecture we will start at 12 a.m. So continue this lecture from why compounding is required from here. So all of you ready for the next lecture? All of you got it? Any doubt, any queries? Hello? Any doubt, any queries? Kunal Joshi? Joshi? Hello? Are you there, Joshi? Hello? Prasad? Are you there? Rishikesh Moge?
Yes, sir.
Vikran?
Yes, sir. Yes, sir.
Sir, no doubts.
Okay. And next lecture will be start at 12 a.m. Continue. Continue from why compounding is required. Okay. Hello.
Okay, sir.
Yes, sir.
Okay. Thank
Okay,
you.
sir.
Okay. Thank you.